Students, this is the help video for the lettered questions in the Unit 6 study guide. There's 3 steps to each of these problems. Step number 1, you read with 3 body parts 3 times. Read with 3 body parts 3 times. Very, very important. You read with your finger on the paper, your lips moving, and your eyeballs tracking with your finger. Let's do this round 1. You do not immediately underline. 3 body parts 3 times. So first time of the 3 times, you're simply reading with the 3 body parts. It said, Mr. and Mrs. Crawley want to design a rhomboid flower garden in their own backyard. The garden is to be surrounded by a brick edging. Consisting of 6-inch bricks. The diagonal lengths of the garden are 12 feet and 16 feet respectively. Find the length of the border of the garden and the number of bricks required for the border. If the bricks cost 75 cents each, calculate the cost of the border. So first time you read with 3 body parts. Second time you go back and you filter. Filter means to underline keywords and all numbers. Then what to decide? A rhomboid. That means rhombus flower garden. It's to be surrounded by a brick edging. Bricks are 6 inches each. The diagonal lengths are 12 feet and 6 feet respectively. You want to find the length of the border and number of bricks, 75 cents, and ultimately we want to find the cost. That's filter. Then last time is that we draw, label, list, cross out. Draw, label, list, cross out. That's this step. 1 step at a time. We're going to draw ourselves a rhombus. As we draw this, we're going to cross items out. Trying to make my rhombus even here. And it's surrounded by a brick edging. Now this edging, so physically touch the edging. We're going to walk our pencil around. This rhomboid garden has an edging. That implies we're going to be finding the perimeter here. The bricks are 6 inches. That means whatever the bricks, however many they are, each brick is 6 inches. Cross that out. We have diagonal lengths, and diagonal means connecting corner to corner. We have a shorter and a longer. It's best to draw this according to scale. 12 feet, that's the shorter one. So I'm going to go the shorter distance. That's 12 feet. And then here, 16 feet is the longer one. Since I know a rhombus cuts the diagonals in half like a parallelogram, I'm going to instantly break this up to 6 feet. And 6 feet. I'm going to break this up to 8 feet and 8 feet. Cross it out as we go. Our goal is to find the length of the border, which in order to find all 4 sides, let's mark what we know about a rhombus. We know that all four sides are equal. So if we can find one side, we can find all four sides. We also know that they cost 75 cents each brick. So the bricks are 6 inches each, and they cost 75 cents each. Ultimately, there's 3 questions. Find the length of the border, that's question number 1. Number of bricks, that's question number 2. And then cost, that's the final and ultimate question number 3. Before you go on, you ask yourself, what do I know about the diagram? You don't ask yourself, what should you do? You ask yourself, well, what can I do? Get rid of that should thought. You just keep asking yourself, what do I know about a rhombus? We already know the diagonals are bisecting each other. We also know the diagonals cut these corners in half. We also know that all four sides are equal, but most importantly, we know, very important, that the diagonals are perpendicular. Look what we have here, folks. We have ourselves a right triangle. So at this point, I'm going to cut you loose on your own. You have a right triangle. You have everything you need. Simply ask yourself, what can I do with a right triangle? There's 5 of them. 1, 2, 3, 4, 5. That is in your reference booklet. Get out your reference booklet and figure that out. You should have finished problem A. Now, once again, you read with 3 body parts 3 times. That's your first step. Step number 1 is always to read with 3 body parts. That's eyes, lips moving, and finger tracking. And you're supposed to read 3 times. 3 body parts 3 times. First, you simply read. Second, you filter. Third, draw label list, cross out. Let's start by reading. In the diagram below, PQRS is a rhombus. SRJK is an isosceles trapezoid, and JKHI is a square. The measure of TPQ is twice the measure of TQP. SQ is 24 root 3, KJ is 14. Find all possible segment and side length and angle measures. Round the side lengths to the nearest 10th place and angle measures to the nearest whole degree. Use the empty space for computational work. Now we go back and we filter 3 pieces of information. PQRS is a rhombus. SRJK is an isosceles trapezoid. And JKHI is a square. The measure of angle TPQ is twice the measure of TQP. The distance S to Q is 24 root 3. And KJ is 12. We're going to find everything we can. Let's start with the basics and ask yourself, if PQRS is a rhombus, what do we know about a rhombus? This is draw label list, cross out. So PQRS is a rhombus. It is important you simply get in the habit of marking everything you know to be true about a rhombus directly on the diagram. Let's start with the basics. Rhombus means all 4 sides are equal. Rhombus also means the diagonals bisect each other. and they bisect these corner angles. Very important. The rhombus not only has 4 sides, but it also has right angles in the middle here. Very, very important. That's everything we know about a rhombus. Now we come down here, and we know that SRJK is an isosceles trapezoid, and we ask ourselves, what do we know about an isosceles trapezoid? Well, if it's isosceles, step number 1 is that we have 2 equal sides. This is isosceles trapezoid. I also know that the base angles are equal, so this angle over here is equal to that angle, whatever it is, and this big angle here is equal to that big angle there, whatever it is. That is an isosceles. Then we know that JKHI is a square. What are some things we know about squares? We know we have 4 equal sides. We know we have right angles. And we know that that diagonal is going to cut that right angle in half. So now we can start getting ourselves some numbers here. So always be in the habit of marking and asking yourself, what do you know to begin with? And we also know that TPQ is twice the measure of TQP. So it's very important you trace that very slowly. TPQ trace and sweep is twice the measure of TQP. Trace and sweep. So this is a 2x and x relationship. Knowing that you have a right triangle there, you should start being able to solve things. You're also told that SQ is 24 root 3. So this whole thing, S to Q, is 24 root 3. If I divide that by 2, I get 12 root 3, which means each of these diagonals here are 12 root 3 and 12 root 3. The last thing I'm told is J to K. K to J is 14. Knowing this, find all, not 14 degrees, just 14 units. Knowing this, find all possible side lengths and angle measures. Obviously, you have right triangles going on here. Let me just highlight them for you so there's no confusion. We have, of course, a right triangle going on here. There's a right triangle going on here. And on the other side, and of course, another right triangle going on here. So you're going to be using your right triangle toolkit to solve for every possible segment length and side length and angle measure possible. Problem C. We're going to read 3 body parts in 3 times. Again, the 3 body parts is with your eyes, your finger tracking, and your lips moving. 3 times you simply read. Second time you filter. Third time you draw, label, list, cross stuff out. Let's follow this order here. Step number 1, we read. Hot Wheels. has been making die-cast models for popular cars for over 50 years. Below is both a picture of the 2010 Mustang GT and its corresponding Hot Wheels model. The length of the actual car is 16 feet. The model is only 3 inches in length. What is the scale factor used to size down the car to the model? So your work. Should have done that with 3 body parts: eyes, fingers, lips. Now 3 times. That was read. Now we filter. Hot Wheels has been making die-cast models. Below is a picture of the 2010 Mustang with corresponding Hot Wheels. The length of the actual car is 16 feet. So 16 feet, underline. Don't forget the units. But the model is only 3 inches in length. Our ultimate goal is to get the scale factor from the car to the model. So we're going to go from the car to the model. Car to the model, and we want that scale factor. In other words, what is the ratio of car to model? Draw label list, cross out. We have our drawing, we have everything labeled, and this is ultimately what we want. View solve. Problem D. Read out loud with me. See the regular polygons below. Extend one side of each shape to create a single exterior angle. Trace along the line. Regular means all the sides are equal. Let's just simply make that part of our processing here. So all these sides are equal. We're going to extend one side, and we're creating an exterior angle. So extending one side to create an exterior angle. So now sweep one exterior angle and sweep the matching interior angle next to it. So one exterior and one interior angle. There's the exterior, keep it together, interior. Keep going. Exterior, interior. Keep going. Exterior, interior. Exterior, interior. Exterior, interior. Exterior, interior. That sweeps and says, what do we notice about a single set of exterior and interior angles? Let's sweep every single one. Ready? Sweep, 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 sweep. You should notice, regardless of how many sides, that the exterior and interior angles are automatically supplementary. So we're going to write that here. That one exterior angle plus one interior angle is always going to equal 180 degrees. So the matching set of interior and exterior angle will always equal 180. That's important to know, regardless of the shape. It's asking over here, what is the number of sides in a regular polygon in which the interior angle is 17 times the measure of the matching exterior? That was polygon, number of sides, so we don't know whether it's polygon or dodecahedron. It's very important to understand that we do not know the n here, which is the number of sides. What we do know, however, is that one interior angle is 17 times greater than that same exterior angle. What did we just learn about interior and exterior angles? We learned that they add up to 180. So this interior angle, whatever it is going to be 17 times greater than its matching exterior angle. Let's watch and write down what we know from the previous example. We know that one interior angle, and we know that one exterior angle has to add up to, regardless of the shape, has to add up to 180. We figured that out from this page. Let's continue. We know that we have here a 17x plus x relationship. That's very important. When you solve for x here, you have not solved the problem. Ask yourself, what is x that you're finding? X is not a number of sides. That's very important to understand that. Ask yourself, what is x? After you solve it, and use that to find your n, which is number of sides. So your x is going to be down here, and you're going to find x. But keep in mind that x is not the same as n, which is the number of sides. And n is ultimately what you're trying to find. Finish this problem on your own. For problem E, use of one inch and regular. Now what we're finding here as to is over side for the interior angles. This one is simply 24 minus 2 times 180 over 24. We're going to see at least plugins for each one of them. Once you have the plugins, 24 minus 22 times 180 divided by 24, and we have one angle right there is going to be 165 degrees. You're going to find all of them, and then you're going to answer these questions, understanding the difference between a regular tessellation and a semi-regular tessellation. For this problem, again, we're reading 3 body parts 3 times. 3 body parts. Finger on the paper, your eyes tracking, lips moving, and 3 times. Then you filter, and then you draw labeled lists cross out. Ready? Let's just read. Draw a rectangle which I, J, are the first, and I, J, are the longer side. The diagonals I, Q, and JH intersect at D. The measure of angle DJK 4 times as large as the measure of I. The length of D is 10 meters. Draw the rectangle in all possible angle measures and side lengths. Now go back and filter. Another rectangle. And it's important in this rectangle that the sides HI and JK are shorter. You want to draw this to scale, please. And IJ and HK are longer. Let's try to draw what looks like that. We want HI to be shorter, so we're going to start by making sure HI is shorter and then make yourself consecutive. HI, J, K. As we read it both clockwise or counterclockwise. Let's see if we did that right. HI, JK are the shorter side. IJ and HK are the longer sides. We did that correct. Now we're going to draw in the diagonals. The diagonal IK and JH. So IK, diagonal means corner to corner. And HJ. And they intersect at the point D. Here's the tricky part. You must trace and sweep this very carefully. DJK is 4 times larger than IJP. Trace and sweep. D, J, K. Trace and sweep at the elbow. Is 4 times as big as IJP. So we go I, J, D. Trace and sweep. So that's 4x, that makes X. We're also told that H to D is 10. So this length right here, we are told, is 10. Let's check to see if there's units. Yes, knowing this, your job is to find all possible side lengths and angle measures, knowing that it's a rectangle. So why don't we start by asking ourselves, what do we know about a rectangle? We know that opposite sides are equal length. We know that we have right angle corners. And we know if you physically trace all 4 diagonals. Why don't we physically trace them together? Let's trace them. From H, D, tracing I, D, tracing J, D, tracing K, D. You need to do it again. You should feel that all of those are exactly the same length. Knowing that, find everything possible in the diagram. Problem G. A glide reflection combines a reflection with a translation along the direction of a mirrored line. Glide reflections are the only type of symmetry that involve more than one step. There's a video for you there as well as a diagram. This is called a combination transformation. In the diagram to the right, plot 2 cycles of a glide reflection of the given triangle. So our first one is we're going to reflect over the y-axis and then translate by 3 units up. Label PQR right in the coordinates. We're going to repeat the same glide reflection. Again, we're going to reflect over the y-axis and 3 units up and call it P secondary, Q secondary, R secondary. Then we're going to predict what the 20th glide reflection would be. So we're reflecting with the y and translating 3 units up. Let's get our original coordinates here. P is at -8, -8. Q is at -6, -4. And R is at -2, -6. We want to reflect over the y and translate by 3 units up. So to reflect over the y means we're going this way. And then 3 units up means we're shoving upward that direction. So just get in mind the direction of the motion that we're going. To flip over the y, you opposite the x. To flip over the y, you opposite the x. To flip over the y, you opposite the x. To flip over the y, you opposite the x. To flip over the y-axis, you're going to opposite the x coordinates. So glide reflection number 1, you simply opposite those x coordinates. That is going to be 8, that's -8, that's +8. -6, +6, -2, +2. And then going upwards on the y-axis, up, so to the y coordinate, we're simply going to add up 3 units. Not 4 units, I think it's 3 units, yes. So you're adding 3 units, and since it's up, that's to the y coordinate only. Why not the x? Because we're not moving left to right, we're reflecting. Use that to get your new coordinates. You're going to draw it, your second triangle. Repeat the same process for your third triangle, and then predict your glide reflection for 20.